that place because I'm
clap along if you feel like a room without a roof.
Hi, I'm Kyra. I'm in 3rd period AP Calculus, and this is Intro to Implicit Differentiation. First thing you need to know is what a derivative is. Derivatives basically measure the steepness of a line that's tangent to a curve, which means you're kind of looking at the slope. When you're dealing with explicit derivatives, you're dealing with two variables that are linked, usually an x. So you're going from f of x to f prime of x, which is when you pull down the exponent and then decrease one power. But implicit differentiation is when you're dealing with variables that aren't necessarily linked, which means you have different variables to solve for. So if you look at this problem, you could solve for the derivative of just x, but you could also solve for the derivative of y. This is what we're focusing on in this video. Okay, let's try out what we just talked about. So here's a practice problem for you to look at. X squared plus y squared is equal to 25. Now if you were just focusing on x, you would just use explicit differentiation, which is when you pull down your exponent and you end up with 2x, and that's the end. Only that's not what this video is about. So that is not the end. We're going to try that again. So you have the same problem. X squared plus y squared is still equal to 25. Now, in brackets here, I put what it is exactly that we're doing. This is the heart of implicit differentiation. You're going to do the same derivative you already know how to do when you pull down your exponent. You still get your 2x. It's just you're also going to multiply by the derivative of whatever x is. So it's going to be 2x times the derivative of x, which is x prime. Then you're going to add to it the exact same process, but for the variable y. So 2y times whatever the derivative of y is, which is y prime. And you know, of course, that the derivative of 25 is just 0. Now, you're going to get so good at this step that you actually don't need to write out this part. And you'll skip straight down to here. 2x plus 2yy prime is equal to 0. Okay? Now, since you're working with implicit differentiation, your goal is to isolate y prime. That's the derivative you really care about right now. So to get closer to that, you're going to pull all the chunks that have the x variable to the other side. In this case, all you're moving is 2x. So you're going to end up with negative 2x is equal to your 2y prime. Now, again, your goal is to isolate y prime. So unfortunately, you're going to have to bust him out of this group. Okay? So y prime is going to be pulled out. And your 2y are going to be in parentheses by themselves. Now, because you want y prime all by itself, you're going to divide both sides by your 2y. And this works because we know that if you multiply y prime back into these guys, you're going to get the same thing. And you can try it out to check. Y prime times 2y will give you 2y prime. And it's always good to check this step because you make sure that you pull the right part of the problem out in your parentheses. Now we're at the very, very end. And now that you've divided both sides by your 2y, you have y prime all by itself. And the very last thing you want to do is check and see if you can simplify. In this case, you can. You have a negative 2 over a 2. So you end up with negative x on top over a y at the bottom. Okay, now we're going to apply some of the basic rules we practiced with this more long problem. So this is your equation. X squared minus 5xy plus 3y squared is equal to 7. We're going to use what I call the zoom in method because what you want is to use implicit differentiation on this portion right here, 5xy. So the way you're going to do this problem is by taking this small chunk first. We're just going to solve for this derivative first. And you're going to break up the problem like this. 5 times xy multiplied together. The result is that you're going to use the product rule here. So it's going to end up being 5x times the derivative of y plus 5y times the derivative of x. So now we're going to derive. When you take 5x, we're just taking that straight from here and plugging it down right here. And the derivative of y is going to be multiplied, which in this case you don't know it, so it's going to be y prime. So you end up with 5xy prime plus, again, you're just going to snatch that 5y from right there and throw it down here. Then you're going to take the derivative of x. But we know that the derivative of x is always 1. So x prime is just 1, which means you don't have to write it. So now we have the derivative of this small portion. And now you plug it in with the other derivatives. So this was our original problem. X squared minus 5xy plus 3y squared equals 7. So we're going to do the derivative of x squared, which you know is 2x, of course, because you bring down the exponent. Then you're going to keep that subtraction sign. Now you just plug in the derivative for this small chunk that we found on the other board, which is 5xy prime plus 5y. Then you solve here for the 3y squared. You bring down the 2, multiply by the 3, you get 6 times your y, which stays, and then also y prime, because we're still doing the derivative of that y. And then, of course, the derivative of 7 is just 0. So next what you want to do is distribute your subtraction sign to this derivative in here. So you end up with 2x minus 5xy prime minus 5y plus 6y y prime equals 0. Next what you're going to do is pull over all the chunks that don't have a y prime in them. So you end up with negative 5xy prime plus 6y y prime is equal to negative 2x plus 5y. Now what you're going to do is isolate y prime, because this is what you're solving for in implicit differentiation. You put everything else into parentheses, and the best way to check this is to just go back in mentally and multiply them back together and make sure you end up with the same thing. So negative 5x times y prime is negative 5x y prime. 6y times y prime is 6y prime. Now you just divide both sides of what you've put in the parentheses here, and you end up with y prime is equal to negative 2x plus 5y over negative 5x plus 6y. You may be wondering, how do I use implicit differentiation when I need to solve word problems? I've got a terrific solution for you. Use cats. Now you're probably wondering, what the heck are cats? This is cats. CATS is an acronym. C, carefully read the problem. A, analyze what the variables mean. T, take your time when you're plugging things in. And S, solve. Now we're going to do some practice problems, and I'm going to show you how you apply CATS. It's so easy, you don't even have to think about it. Now we're going to practice with a word problem. Suppose the quantity demanded weekly of super tighten radical tires is related to the unit price by the following equation, where x is measured in units of 1,000 and p is in dollars. 4p squared minus 50x squared is equal to 1,600. How fast is the quantity demanded weekly changing when x equals 16, p equals 60, and the price per tire is increasing at the rate of $5 per week? So, the first thing you want to do with this kind of problem is that there are a lot of variables. You want to define them and make sure you understand what's going on. So, what exactly did you just read? You read that p at this moment p is measured in dollars, and at this moment it's at 60. So that means that the rate of change with p will be dp dt, and it happens to be $5 per week in this scenario. Then you learn something about x, which is measured in thousands. And in this scenario, it happens to be at 16. The rate of change for x is dx dt. But that's what you're solving for. Okay? So next, we're going to jump in and figure out exactly how we're going to take that question and those variables and put together our works. So, the first part of your equation was this. 4p squared minus 50x squared is equal to 1,600. What you're going to do is you're going to use implicit differentiation here. So, just like a regular derivative, you're going to pull down the 2 and multiply by the 4 and get 8p. And then you're going to multiply by p prime, because you're also going to take into account the derivative of p, which, like I said in the other board, is dp dt. We're just writing it as p prime. Same thing. It just means the derivative of p. Then you're going to subtract 100x, because you're doing 2 times 50. And then you're going to also take the derivative of your x, so you end up with x prime again, which is the exact same thing as dx dt. Same thing, we're just writing it differently. And then the derivative of any number is just 0. So this is what it is that you're going to solve for. And now we're going to solve. And now we are about to jump into the good stuff. So, again, this is our problem. 8p p prime minus 100x x prime is equal to 0. Once again, p prime is the rate of change for your p, and x prime is the rate of change for your x. And we're trying to find x prime. So, you're going to move everything else to the other side because it's kind of irrelevant here. So, you end up with negative 8p p prime is equal to negative 100x x prime. Next, you want to isolate that x prime. So you're going to basically imagine that you put parentheses right here and divide both sides by the value in here, negative 100x. So you end up with x prime is equal to negative 8p, p prime, over negative 100x. Now, you're going to plug in the values that the problem gave you originally, because they gave you all of these values on this other side. So, they told you that p was 60, and they told you that p prime, which was the rate of change for p, was 5. So you can sub in those variables. They also gave you x because they told you you're at 16. So you can sub that in as well. You're going to multiply these together just as they're written, and you're going to end up with negative 2400 over negative 1600. Now, of course, we can cancel out these zeros, and then the negative over the negative just becomes a positive. So you end up with x prime is equal to 1.5. Okay, that's not okay. Okay? But they also told you that x was measured in thousands. So now you're going to take your 1.5 and multiply it by 1,000. You end up with 1,500, which is your final answer for x prime. In that first problem we did, cats kind of came easily because that was a really simple problem. I'm going to remind you again of what cats means, and we're going to jump into the second word problem. C is carefully read the problem. A is analyze what the variables mean. T is take your time before you plug things in. And S is solve. So let's jump right in with our second word problem. Suppose that the wholesale price of a certain brand of medium-sized eggs, P, in dollars per carton, is related to the weekly supply, which is X, in thousands of cartons, by the following equation. 90p squared minus 3x squared is equal to 240. If 10,000 cartons of eggs are available at the beginning of a certain week, and the price is falling at the rate of 2 cents per carton per week, at what rate is the supply changing? And round your answer to the nearest whole number. Now, this problem is different than the first one we tried because it's got a lot of tricks going on. So before we jump into actually working on the problem, we're going to focus on the carefully reading part of cats. So, first of all, you're going to get a lot of unnecessary information. For example, nobody cares what size the eggs happen to be. So you can ignore things like that. But things that always matter are what your variables stand for. P, which stands for in dollars per carton, is very important, as is X, which stands for the thousands of cartons that you're getting in the weekly supply. Now, there are a few tricks that this problem has included. The first being that the price is falling. It says so right here, which means it's negative. It's decreasing. Here's the other trick. They give you a rate of 2 cents per carton per week, but your equation is measured in dollars. So you got to convert that 2 cents to dollars, which means it's 0.02, and again it's negative because said part is falling. Okay? Then the next big trick comes here. They ask you about 10,000 cartons of eggs, but you're told up here that X is in thousands of cartons. So X is not 10,000. X is only 10 because you're measuring in those thousands. So you can see now why it's really important to carefully read, because problems will try to trip you up. We already began our problem with C, which is carefully reading the problem. Now we're going to jump into A, which is analyzing what the variables mean. So, we have two variables in this problem, X and P. Each variable also has a rate in this problem. You can write the rate as dx dt or dp dt or x prime or p prime. So, in this situation, we're already given x, which is 10 because it's thousands of cartons. And what you're looking for is dx dt, which is equivalent with x prime. In this problem, you aren't given p, but you are given p prime, which is dp dt. We already solved for it on the other board. It's negative, and it's 0.02 because it has to be in relation to dollars. So the first thing we need to do is solve for p, which we can do by using the original equation we're given. Let's solve for it. So this is our original equation. 90p squared minus 3x squared is equal to 240. Now this part is basic algebra. You're just going to isolate p, and it ends up being the square root of 6. It's only the positive square root of 6 in this case because we don't have a negative amount of dollars. That's not something we're going to deal with. So p ends up being square root of 6. Now we can get down to solving for x prime, or dx dt, and that's the part that's going to require implicit differentiation. So, just like our previous problems, we're going to start with the original equation, and then we're going to derive. 90 times 2 is 180 times p times dp dt, which is the same as p prime. 3 times 2 is 6 times x times dx dt, which is x prime. And the derivative of 240 is just 0. Next, you're going to isolate x prime because that's what you're solving for. So you're going to move the 180p p prime to the other side. Now you're going to pull x prime out from his big bundle because you want him by himself. Again, you can check this step because x prime times negative 6x will get you negative 6x x prime, which is what you want. Now you're going to divide both sides by your negative 6x that you pulled out of this bundle. That way you end up with x prime by itself. At this point you'll have negative 180p p prime over negative 6x. Now you can just plug in these variables because you found all of these things already. You already know that p is root 6 because we just solved for it, and you know what p prime is because it's the rate of change for p, which we also found to be negative 0.02. You know what x is because it's given to you in 10,000 cartons. Since we're measuring cartons in thousands, it's just 10. You plug in, you multiply, you solve, and you'll end up here. 8.818163074 over negative 60. I wrote out the entire decimal that I found on my calculator to be as accurate as possible. In the next clip, I'll talk about what that looks like. But for now, just know that you want to have this accurate number for when you divide. Then you'll end up with negative 0.147 because you're rounding to the third decimal point. But because we're talking about thousands, don't forget to multiply by 1,000 again, because the problem says you have to have a whole number, and you'll end up with negative 147. Okay, we already talked about this part on the other board, but I want to show you your best friend in AP Calculus, which will be your graphing calculator. It's really important because when you have steps like this where you have to multiply by a square root, it's going to use the exact number without you having to write down a ton of decimal places. So, in this step right here, your 1469 becomes 147 because you round to the third decimal place. And then when we multiply by 1,000, that's how we end up with the answer negative 147.
Equal 13. Now we find the equation of the tangent line. Y'all know what I mean. So we implicitly differentiate. We hope this gesture y'all appreciate. Once we do that,
Okay,
we get
now we're
down
going to start
here.
with the first
We like
step
to do
in calc,
calculus with
which we did already.
Back
So
around
I'm
the
gonna
y
do it kind of
prime, get the
start.
4x plus 2y. Yeah, we all do that in time. Now we move this to the other side. All we gotta do is divide. Take the points and find the slope. Now don't you squirm, cause we got this down here in point slope form.